Bismillahirrahmanirrahim. Dear students, this is the second video of the course of ENA, and in this course I will be covering first order circuits RC step response. That means when RC circuit also involves a power supply. But before that, I will just like to here mention a hadith of Muhammad sallallahu alaihi wasallam. Muhammad sallallahu alaihi wasallam said that कि अल्लाह जल्ल शानहू का इरशाद है कि मैंने तुम्हारी उम्मत पर 5 नमाज़ें फ़र्ज़ की हैं और इसका मैंने अपने ऊपर अहद ले लिया है कि जो इसको अपने वक्त पे अदा करने का एहतमाम करेगा मैं उसको अपनी ज़िम्मेदारी में जन्नत में दाखिल करूँगा, और जो इसका अहद ना करे, जो इसका एहतमाम ना करे, उसकी कोई ज़िम्मेदारी मुझ पर नहीं। तो अल्लाह सुब्हानहू व तआला कहने सुनने के साथ अमल की तौफीक अता फ़रमाएँ। जिस तरह के हालात हैं इस तरीके से हमें ख़ास तौर पर अल्लाह की तरफ रुजू करने की ज़रूरत है। तो नमाज जो है वो इंसान मुसलमान के लिए सबसे बुनियादी दर्जा रखती हैं, इससे कम कोई दर्जा मुसलमानों का नहीं है। कहा कि इस्लाम में कोई हिस्सा नहीं है उस शख्स का जो नमाज ना पढ़ता हो, और इस्लाम और कुफर के दरमियान फ़र्क करने वाली चीज़ नमाज का छोड़ना है। अच्छा, तो ये मेरा ईमेल एड्रेस है। फॉर ऑल ऑफ योर क्यूरीज you just please mail me on this hashmani@gmail.com. Then I will be just checking it, and then we'll make a video of answering your queries. Right, so now I start my lecture here. This is the thing. Okay, I start with the step response of a RC circuit. Here we start. This is the topic 7.5 which I will be covering today. Okay. The step response of a circuit is the behavior when the excitation is the step function, which may be a voltage or current source. So this is the statement of a step response. Step response means this. The step response means that there is a capacitor, and then a power supply is connected through a switch at time t is equal to 0. At time t is equal to 0, the switch gets on. So this switch can be here or here, it does not matter because the resistor is just a passive device, it does not store any energy. So this switch can easily be switched without affecting any of the further discussions. So eventually this because we have just applied this this power supply at t is equal to 0, so if we just multiply it with this u of t is a step function which is 1 after time t is equal to 0, and it's 0 for all other times. That is, time t is equal to 0, less than 0 it is 0, and for time t is equal to greater than 0 it is 1. So it will only be applied, this power supply will only be applied at time t is equal to 0. It is just a replacement of the switch. For capacitor, the capacitor cannot change voltage suddenly. So voltage of a capacitor at time t is equal to 0 superscript minus, just before 0, that is minus, and this is just after 0, time t is equal to 0. So the both of the voltages is going to be equal. So if the initial voltage was of the capacitor on the capacitor was V0, so it will remain V0 after applying this power supply, after connecting this power supply. There is not going to be any change sudden, but eventually then it will start changing the voltages. So what shape it is going to take is the current discussion. So what we will be doing is we will just apply KCL here in this circuit. In this circuit I will be applying KCL. So the current direction is downwards in this capacitor, and this current through the resistor is on the left side. So this will become current through the capacitor is C dV by dt, that is IC is equal to C dV by dt plus the current in this branch resistor towards the left in the mouse direction, which I am just dragging this direction, right? So it is going to be, the current direction is always going to be equal to the voltage of the tail of the arrow, current arrow, minus the head. So this voltage minus this voltage minus this voltage. So the voltage at this point of the resistor on the right side of the capacitor is the same voltage as of the capacitor. So this V and this V are same. Okay, minus the supply voltages, that is Vs minus Vs U of t, and the current is definitely we will have to divide it by R to get the current. So this is the voltage difference and this is the divide by R, so that it means this is the current through the resistor, because we have taken the directions all going outwards into the capacitor and then from here this point into the resistor. So the sum of the capacitor should be the sum of the currents should be 0 according to the KCL. Okay, dear students, there was a bit of interruption. So this is the current, and so this current plus this current is equal to 0, KCL. And then there are some adjustments and then manipulations of the equation, and we get the final form of dV by dt is equal to, you please go through and try to understand all the steps and then reach here. These are very simple steps. So dV by dt, and so then simple steps, and then we reach this equation, this one. So anything dV by upon the variable, that is ln, derivation is ln. So ln of V minus Vs, the power supply voltage, this is constant and this is the variable, right? So here we are applying the limits for this variable. So this is going to be V of t, the capacitor voltage, and this is going to be the initial voltage of the capacitor, the initial conditions. So where we want to integrate it, we want to integrate this V, the variable of interest, the variable of integration, that V to the current value, that V of t, and starting from V naught, that is the initial condition. And what is going to be the time? We are starting from time t is equal to 0 and going all the way to time t. So this here the variable of integration is t, so we are applying the limits in terms of t, and here the variable of integration is V of t, so we are applying the limits in terms of the same variable, that is Vt and V naught. Right. So after some just manipulations we reach this final state, that is V of t, the capacitor voltage, is going to be equal to the supply voltages plus the bracket open, the initial voltages minus the supply voltages, bracket close, and then e raised to power minus t over tau. And we already have discussed this, we already have just mentioned here that the tau is going to be RC. This has come from here, right? T upon tau, tau is this, so here it is mentioned T over tau. I hope this was simple enough for you to understand, but this is a very important concept. You must go through all the steps and then you are convince yourself that you have understood and grabbed all the necessary concepts here. It will not be clear in the first watch or first read of the book, so you must go through this through the book yourself. After watching this video, you try to just get this PDF file open on your computer and then try to understand all the steps. And I just tell you that I will just suggest that you watch this video by just pausing at various points, so that you get the complete understanding. And you should also have the PDF file open in your PDF viewer, so that you can see the contents and scroll them down or scroll them up, so you can see what is in the book. With this video lecture is not much different from our classrooms, I feel, because my style of classroom teaching is always to flash the book on the multimedia screen rather than my presentations, because what I feel is that the book is the actual source of the information, and if I just try to make the presentation, which I already have, but I don't prefer to use them, because then I feel that some information is just missed out, and then you don't get the complete feeling of getting the complete understanding and complete contents. So I always try to read my own reading. I always like to read from the actual source, that is book. So I will also urge upon you to go through the book. right? So thus for time t is equal to 0, the voltage is going to be V naught, and then for time t is equal to greater than 0, this is the equation which we have just reached here in this step of 7.45. so they have just combined these two parts of the V of t in 7.46. now this is the complete response definitely. So uh, so after applying the certain voltages of DC voltages, assuming the capacitor is initially charged, so the capacitor was initially charged at V naught, and when you apply the supply voltage Vs, it is going to be taking this shape of exponential rise, and then it will reach the final status or state of supply voltage Vs. Okay, so if the capacitor voltage is considered as V naught as 0, so this whole graph is going to come down and V naught is going to be equal to 0. This is very simple enough. So when V naught is equal to 0, so V naught will just go out, and then we will have just this equation. If you just I just scroll the equation again just to show that if V naught is 0, then this equation is going to take the same shape. So this was the equation. So if we just make it 0, what will happen? This is going to be equal to Vs plus minus Vs multiplied by e raised to power minus t over tau. So it will become 1 minus e raised to power t over tau, and Vs will multiply by here bracket. So this is simple enough. You just see from the PDF file and just convince yourself, which can be written alternately as okay. So these two conditions are just combined in one equation if you just include a step function here u of t, right? If you want to multiply, if you want to get a current through the capacitor, so the current of the capacitor you will have to derivate it c dv by dt. You derivated c is here from the c dv by dt, and tau is the from the derivation tau here, then tau is rc. So c will cut out from numerator and denominator, and the only part that will remain is the r, Vs over r e raised to power t over tau u of t. So this is the current. This is the current. This equation is going to take the shape of this graph. The current will keep decreasing as the capacitor gets charging. The current will keep decreasing. The capacitor voltage will keep increasing, and the capacitor current will keep decreasing. So this is what it will happen. Okay, so now there are two ways of dividing the complete response of this RC and RL networks. The complete response is comprises of two parts: the natural response and the forced response. You know, where natural response is the response due to the initial voltage, charged voltage, the initial energy that is stored in the capacitor, that is V naught, is the voltage across the half C dV naught square. So this is V naught, and this is the forced response that is only due to the presence of the power supply in the circuit, right? So natural response is just because of the V naught, so that's why we have just means written separately the terms involving V naught. So this is going to be the V naught natural response, and all the other terms we have just combined here where there is no mention of V naught, so that is just due to the Vs, that this is forced response. So there are two ways of discussing the complete response. One is in the terms of the natural response due to the initial energy, and the forced response that is due to the power supply. The other way of describing the same response is in the form of the transient response and the steady state response. So this is the detail which I already have covered in my discussion. So the other response, complete response, is equal to the transient response and the steady response. So transient response is Vt, in this Vt, and the steady response is Vs. So transient response is all the response that involves e raised to power minus t over tau, the exponential. So this is the transient response, and eventually Vs is the supply voltage. So the complete, after settling down all the things, the capacitor is going to take the voltage of Vs, the supply voltage, because the capacitor is getting charged by a supply voltage of Vs through a resistor So eventually after some time, or we can say the after 5 time constants, 5 tau, that is what we take as a time period after which the transient response dies out. So this is going to be Vs. Alright, so these are two statements. The transient response is the circuit's temporary response that will die out with time. The steady response is the behavior of the circuit a long time after an external excitation is applied. That is the power supply. External excitation is the power supply. Okay, just let me see how long I have just gone. So I already have covered 15 minutes, so I will just take one few more minutes or 5 minutes more. I will just try to keep my videos to 20 minutes. The first decomposition, what is it? Okay, so as we have already just divided into a transient response and the steady state response, so this is we can just say the complete response. This is the steady state response, V infinite, and Vs, it is the infinite. After settling down, Vs is going to be the final voltage of the capacitor. That's why we have just said it as V infinite, and this V naught is the voltage of the capacitor at time t is equal to 0. In this way we will just reach a very easy method of tackling this RC network with a step response of RC network. So what we will be trying to find, we will try to find the key. First we will try to find the V naught, that is the voltage of the capacitor before applying the step excitation, and then we will just try to find out the steady state response, that is the what is going to be the voltage at the after 5 time constant, that is V infinite, and then we will also try to find out the V time constant of the circuit, and that is always equal to RC. Right, so here I already have described, but I will just try to read it out. Said that we obtain 1 from the given circuit for t less than 0, and items 2 and 3 we will get it from time t greater than 0. Okay, so this is it. This information is not right now so important for us to tackle this the numericals. So you try to just understand the example. This is a solved example 7.10, but I will just show you the practice problem 7.10, and here this is the main circuit. After at t is equal to 0, this switch goes on, so this power supply gets connected, but before it the only part that is relevant for time t less than 0, this one, this thing. So I will just solve this question. I will just show you, and then what we have to find out, we have to find out the complete response for t greater than 0, and we also have to find out the voltage of the capacitor at time t is equal to 0.5. So once we get this equation, what we will do is we will just put 0.5 at here in t, so we will get this voltage of 0.73. But I just mentioned you that I have tried to solve this question, and I just found out that this value is a bit of mistake, and there is coming a difference in the final result. This much is okay, but this has some errors, so I was just not able to reach this final result. My value is a bit different. Alright, so I will just show you my solution. So this is the circuit for t is equal to less than 0, so V naught is going to be equal to 15, because this is the capacitor is being charged with the 15 volt power supply through a resistor, but this value of this resistor doesn't matter because this capacitor will eventually get charged to the same value. Right, so for t greater than 0, this switch will get on, and this supply will also come into the circuit. So we already have found V naught. Now we try to find out what is going to be the voltage of this Vc. This is the original place where the capacitor was connected, but I have just eliminated it and have shown the open circuit, because capacitor after getting completely charged becomes open circuit. So that's what we want to find out. So applying the loop here, if I just assume that the I current is passing through this, and applying KVL here, so minus 15, 2I, 6I, plus 6I because the current is going into the capacitor, and then minus 7.5 because the polarity is minus 7.5 is equal to 0 because we already have reached the initial point where we had started from. So this point we had started from, all going all the way and applying KVL, so we reach this, and this I comes out to be 2.8125. So if I just want to find out what is going to be the voltage of this point with reference to this point, so I will have to apply another loop here. So that's what I have done, that minus 15, 2I plus Vc. So from here the Vc comes out to be 9.375. so that we can just write the complete response. This is the original equation where we have to just put in the values. V infinite is minus 9.375, this is minus 37.75. This was the initial voltage charge 15 volts minus again the V infinite where everything has settled down 9.375, the same value, and then e raised to power minus 2t. Where this 2 has come from? This 2 has come from this by finding out the tau, this tau. So we just short circuit both of these two supplies, 15 volt supply and this 7.5 supply. So the circuit reduces to a capacitor and the two parallel resistors. So if you just find out the tau RC by finding out the parallel combination of these two resistors with the capacitor, so it comes out to be minus 1 upon 2, that is 0.5. If you just bring 0.5 in the denominator, tau at the place of tau, so this will become 2t. So this is 2t, and then putting the values of 0.5 in at the place of t, so this comes out to be 11.14. so I will just show you the next numerical after 7.11 practice problem. I just give a lot of emphasis on the practice problems. I will just also be giving you the end of the chapter relevant problems for you to practice, but practice problems are extremely important, and they are bare minimum that you should attempt yourself. Without this you cannot prepare for the final exam, so you will not get the the contents that are being discussed here. 7.11, so this is 7.11. you just have a look on it and then try to find out the result yourself, solve it, and if you have any problem you just refer this video, and then all the steps are mentioned here. So this is it. So hopefully this video will help you understanding this topic. Next I will keep posting the videos, and till then, Allah Hafiz.